Hello everyone, welcome back. In this session, we'll build the Flight MCP Server for our Agent Network 2.0 project using the MuleSoft MCP Connector, deploy it to CloudHub 2.0, and validate its tools using MCP Inspector. I have already built this MCP server from scratch using latest MuleSoft MCP Connector and uploaded the complete source code to GitHub. I'll provide the repository link in the description below so you can clone the project, review the implementation, and deploy it directly to your own environment. For this demo, I have deployed the application to CloudHub 2.0 using a minimal configurations. Let's validate it using MCP Inspector. I'll also include the MCP Inspector setup instructions in the description below. In MCP Inspector, navigate to the Servers section and select Add manually. Change the transport type to Streamable HTTP. Next, copy the public endpoint of your deployed Mule application, append /MCP to the URL, and paste the complete endpoint into MCP Inspector. Once the connection is established, MCP Inspector automatically discovers all tools exposed, such as search airports, get fare rules, get flight details, book flight, search flights, and check seat availability. Let's test the check seat availability tool. I'll provide the flight number, departure date, cabin, and passenger count. Now, let's execute the tool. Great. The Flight MCP server has processed the request and returned properly structured information. This confirms that our MCP server is deployed successfully and is ready to be connected to the travel planner broker in our Agent Network 2.0 project. Now, one important question is, where is this flight information coming from? Is it live airline data? No, this demo does not use live data. To access real-time flight schedules, seat availability, and pricing, you would normally need a paid subscription from a commercial flight data provider, global distribution system, or travel aggregator. Because those services can be expensive and require commercial agreements, I have created a mock flight dataset specifically for this Agent Network 2.0 use case. The dataset contains 16 airports, 22 flights, seat availability information, and sample fare rule summaries. This mock data is included in the GitHub repository, so you can use it immediately without depending on an external flight data provider. Now, let's look at the most important part, how this Flight MCP server has been implemented. As mentioned earlier, I built the server using the MuleSoft MCP Connector. Let me walk through its implementation step by step. Inside this Mule application, I'm using MuleSoft MCP Connector version 1.6.1. To expose our 6 flight capabilities as MCP tools, I have created a dedicated MCP Tool Listener for each tool. Therefore, you can see 6 separate MCP Tool Listener flows in this project. Let's walk through one of these tools end to end. From the Mule palette, search for the MCP Connector and drag the MCP Tool Listener component onto the canvas. Before configuring the individual tool, let's open the global MCP server configuration. This is a very important part of the implementation. Once the global MCP server configuration is complete, save it and return to the tool flow. Now, configure 3 important properties for the MCP Tool Listener: the tool name, the tool description, and the parameter schema. The tool name uniquely identifies the capability being exposed. The description explains what the tool does and helps the broker's LLM understand when it should invoke that tool. The parameter schema defines the inputs expected by the tool. It specifies each parameter's name, data type, description, and whether the value is required or optional. This is the same schema that MCP Inspector uses to generate the input fields when we select and test a tool. Let me show you the schema for the Search Flights tool. Inside the Properties section, we have fields such as origin, destination, departure date, adults, cabin, and non-stop. Each field has its corresponding data type. For example, origin and destination are strings, adults is a number, and non-stop is a Boolean value. The mandatory inputs are also listed in the required section of the JSON schema. This ensures that the MCP client provides all essential values before invoking the tool. We follow the same implementation pattern for all 6 tools exposed by our Flight MCP server. Now, let's go back to the flow. For the tool response, I'm returning the result in text format because our current Agent Network implementation exchanges text-based input and output with the Flight MCP server. Now, let's see how the response is generated for the Search Flights tool. I have created a dedicated subflow that contains the complete flight search business logic. Let me open that subflow. Here, this DataWeave transformation reads the mock flight data included in the project. On the left-hand side, you can see the supporting JSON files, including the flight data, airport information, and fare rules. These files provide the mock data required by our 6 MCP tools. The DataWeave logic filters the available flights based on inputs such as origin, destination, travel date, cabin class, passenger count, and non-stop preference. It then calculates and formats the final tool response. You can explore the complete DataWeave logic for each tool from the GitHub repository. In a production implementation, this subflow would connect to a live airline API, global distribution system, travel aggregator, or another enterprise reservation system instead of reading mock JSON files. In the next session, we'll connect this Flight MCP server to our travel planner broker, deploy the complete Agent Network 2.0 project to CloudHub 2.0, and test the end-to-end flow.